So welcome to the OT and IIoT or Industrial IoT Security section. My name is Mark Simos, Lead Cybersecurity Architect at Microsoft. Hafid?
Hafid Elabdellaoui, Chief Security Advisor for US Manufacturing with Microsoft.
Cool. So when we talk about OT and IoT security, today we're going to actually focus specifically on operational technology, sort of SCADA and ICS, supervisory control and data acquisition, industrial control system, and industrial IoT specifically. There are also Internet of Things, native Internet of Things devices that are outside of the corporate network and providing business value and potentially security risk as well. But we're going to focus less on those and more on the computers that control the physical processes within the organization. So the first biggest thing here, and I'm really interested in getting your perspective as well, Hafid, is when security people start with the default of how they approach the OT environment space, they go in with the assumption that it's going to look like IT because these are Windows and Linux and embedded devices, and they're running some sort of software and applications on them. Oftentimes varies quite a bit. And they think that, hey, we're going after the same thing as normal: confidentiality, integrity, and availability, which is that CIA triad that just about every security professional knows. But the thing that I think surprises most folks is that confidentiality isn't actually the first security assurance they're looking for. They're actually looking for safety because of the physical presence of these machines in the real world and the ability for them to harm people, either physically themselves or through the products that they're making or altering, etc. And so that's I think the first culture shock that IT security experts get when they start looking at OT. Any thoughts, experiences there, Hafid?
Yeah, so that's an excellent point, Mark. We really need to learn a lot more from the folks that are operating the plants. I'll give you an example. I worked in the electric industry for a long time. And when you think, for example, about large companies in the US and outside the US who are operating nuclear plants, safety is number one to protect not only the employees and contingent workers who are working in those plants, but also all the neighbors that live within the perimeter of that nuclear plant. So God forbid something bad happens, it could impact not only the employees that are in that area, but also certainly for all the neighbors and communities that live around it. The other thing is the availability. So when you think about how an organization makes money, it's really those plants being available as much as possible, 100% of the time, whether it's generating electricity or making products or whatever product.
Processing chemicals, taking oil out of the ground, whatever it is. Yep.
As well. Yes.
Yeah, and then the other thing that I think is a little bit shocking to IT folks, because we're used to, when we're in the IT environment, like 5 to 10 years is old, like really old. Right. But when you start looking at the physical hardware that's being controlled, some of this stuff is 50 to 100 years old. And there's actually sometimes still steam-powered equipment that's being controlled by computers that were these computers were modernized this equipment 30 to 50 years ago, 1970s, 1980s, 1990s, and just the newest stuff in there is sometimes older than anything in the IT environment, and so you end up with this. This assumption that, wait a second, we do IP controls and we want to do identity controls and OAuth and SAML and all this wonderful new stuff, and there's a place for that. But what you're dealing with industry-specific protocols that oftentimes have to be bridged to the IP network because they don't actually speak IP natively. And so that's the other thing I think that shocks a lot of IT folks as they start to understand this OT world, is that the lifetimes here are just so very different.
Yeah, so that's an excellent point, Mark. So, and from my background working again in the electric industry, I can tell you, for example, building a gas generation plant costs somewhere between $600 million and $1 billion to build. Or some folks who are building nuclear plants today, that can cost anywhere between $20 and $30 billion. So from that perspective, there's a lot of capital that's being spent up front to build these plants with state-of-the-art technology, and that has to be expensed over a long period of time. So as you mentioned, 20, 30, 40, and even 50 years. And once it gets to that point, organizations are really looking for ways to extend the lifetime of those plants. And today, some of the plants that we've had, for example, for 30, 40 years, we're looking for how do we put IoT devices around those plants and being able to pull data and be able to make some smart decisions, if you will, even though these plants were built 30, 40, 50 years ago.
Yeah, because if it ain't broke, don't fix it. Why do you want to go ahead and tear down something and build something new if it's working well, it's working efficiently, and you can get a little bit more out of it with, you know, some data and some insights to it on the temperatures and maintenance schedules and whatnot.
That's exactly right.
Yeah, and so that leads to quite a challenge, because most of the cybersecurity best practices and most of the technology that's been built has really been built for this stuff in the past 5 to 10 years, maybe a little older, but it's really focused on that. And so when you start looking at the OT environments, you have to look at them quite differently than IT. And so it always helps to start with sort of the language of how of the environment, how it's being used. And the de facto language in the OT space is something called the Purdue Model. And the Purdue Model, you know, effectively is about 4 or 5 layers. I always forget they start at 0. And it defines, okay, you have your actual physical process, right, at the lowest level. And then you have the basic control, the chip that tells the arm to go up and down or whatever the case may be, or, you know, actually opens or closes the valve or whatnot. And then you have, okay, we need to have a coherent sort of end-to-end production line, or, you know, a steam pressure valve, you know, assembly or whatever it is, something that's coherent with multiple sensors. And then you might have multiple ones of those in a plant, in a manufacturing site, et cetera. And so that's really where level 0, 1, 2, 3 come in. And those are fairly static, right? Those things plus any safety systems that are wrapped around them, that is still valid, and it's, you know, it's valid since the 1990s when this was done, early 90s. As you get into levels 4 and 5, though, the thing that we've learned about that Purdue model, because those assumed how the networks were set up in organizations, again, in the early to mid 90s. And so those level 4 and 5 of, hey, a local site network versus an enterprise network may or may not actually still be the right way to think about these. Because we're starting to see the way networks are being transformed on the IT side, where the internet is really becoming the communications backplane, much more so than a corporate network, that we're starting to have to rethink this, and how do we think about securing those devices that attach to the IT level pieces of it, and the identities that flow over it, and all the other elements of it. And, you know, we have Zero Trust referenced in here. And I want to be very explicit about this. Zero Trust is not just, you know, an identity perimeter or versus a network perimeter. It's not just one thing. Zero Trust are principles, you know, through the Microsoft point of view, that assume breach, verify explicitly, and use least privilege access. These aren't things that are tied to any one specific protocol or technology. So you can apply these principles in the OT environment, and we'll show you how, but they are applied within the constraints of it. And sort of those old protocols that we mentioned. Hafid, any thoughts to add there?
Yeah, I'm so glad you hit on the fact that Zero Trust principles don't only apply to identity and device. We spend a lot of time talking about identity and device just because the digital transformation that many organizations are going through really have pushed that network perimeter to be all the way out in the field for IoT devices and the computers that we have in our homes, et cetera. But those principles, I agree with you, 100% can be applied to infrastructure, can be applied to application, and certainly can apply to network from a network segmentation perspective. And I would add to whenever you are dealing with an OT environment, that should be considered a privileged environment, period, no questions asked. Knowledge workers should not have access there, and should be only administrators, and you're managing their privilege, their accounts, and the infrastructure in a as if they're managing privilege assets, if you will, in the corporate environment.
Yeah, need to know, don't get it unless you need it kind of thing. Yep. And so the other thing, just to kind of finish up on what you can sort of expect as a baseline, because we do see some organizations have done a great job of cordoning off and separating these OT environments from their IT. Some organizations still have a flat network that literally extends to the OT environment. So we do see different variations of maturity when we talk to different customers. And so we see some different variations there. But one of the things that we typically see, assuming that the networks are separated, is an exception usually made for business analytics. So if if you're running, whatever it is, a power plant or something like that, someone's got to be keeping an eye on that. So if you have a manual process that is completely isolated, great, which I would hope is the case in a nuclear plant, given the risk. But you may have just simply a manufacturing line or something that's a little bit less business impacting, but still high business impact, but not necessarily lives of an entire city or something. And in that case, we do see a decent amount of times where they have that sensor in the environment that's kind of keeping an eye on production and temperatures and whatever the case is. That's feeding into oftentimes an on-prem business analytics or a console or operator console, so people can keep an eye on that while still checking their email and doing their day job. So, sometimes this is okay, we'll talk about the separation in just a moment, actually, but that's kind of a business function we do see because people need to actually run their business as well. And then the thing that we're seeing that's happening in these environments is really a convergence of cybersecurity attacks or blended attacks, because the attackers really don't care. They ultimately have IP connectivity between these environments potentially, and they will use an IoT device, anything as simple as a fish tank sensor to get into an IT environment. They'll use the IT environment to get in the OT environment. They will move between these environments as they are able to, depending on the configuration, because they're trying to get an objective done. They're not really going to constrain themselves to, oh, we're only doing IT today. Oh, we can get in the OT environment. Let's see what we can get there. So we see that the attackers, quite frankly, are very flexible, and you have to look at this through the attacker's lens, and you can't pretend that if we're protecting IT, we're fine, and then we can ignore the OT. You have to really look at this through the attacker's lens of it's all one set of potential targets. Any additional thoughts there?
Yeah, so those are all excellent points, and one of the things that really an organization like cybersecurity needs to focus on, working certainly in conjunction with those who operate the plant, whatever that plant is, so whatever that OT environment is, and really understand the risk and how that risk needs to be managed. A nuclear plant, for example, it is by law that you have from the Nuclear Regulatory Commission that you have to have an air-gapped environment. So what we see a lot of the nuclear plants do is have one-way communication with data diodes. The communication is one way from the nuclear plant to perhaps a DMZ, and then from DMZ to a corporate network with very specific data that is processed that way. Certainly, other plants that may not be as critical, not have that much impact on the environment or on the organization itself from a revenue perspective, doing some segmentation, like you mentioned, Mark, with physical separation with or even logical separation using next generation firewalls, ensuring that there's a DMZ between the corporate environment as well as the OT environment. And then you can really decide how you want the traffic to flow. And as I mentioned earlier, manage it as a privileged environment, and that will go a long way. And when I say manage it as a privileged environment, it needs to be a different security zone. You can't, for example, use the same identity like directory services that you use in the corporate environment, use in the OT environment. Those really need to be separated. Multi-factor authentication for any required remote access, certainly limit that as much as possible. But some of the areas, for example, like the electric industry, which is really very important to have continuous capability to deliver electricity to customers. I mean, I'll tell you, one of the things that we did is we tested on a quarterly basis our capability to totally disconnect our plans from the corporate network. I mean, we literally went to the switch and unplugged the network cable and made sure that we were able to operate with without any connection to the internet. So again, based on that risk, you need to make sure you have the right provisions in place and that you test your capabilities so that when that time comes, you're able to operate independently of having internet access.
Absolutely. Yeah. I mean, just like you would for, hey, we're seeing a lot of ransomware attacks, we should have an exercise and a practice on it.
Yes.
You need to be practicing those procedures and making sure the processes work, the technology works. People know what they're supposed to do, and they built that muscle memory of what to do.
Absolutely.
And it's important to keep in mind that there's a very large variance in OT environments. The nuclear plants being absolutely at one of the more extreme ends of it. But we are seeing, for example, in manufacturing, there's a lot of interest and a lot of use of, cloud capabilities like digital twins, where you can have essentially a digital copy of your physical processes. There's a lot of analytics and capabilities and test cases that you can really do some amazing stuff to accelerate your business in one of those sort of less stringent environments. So we're seeing a lot of connections to both Azure and third-party cloud analytics of similar data sensors or new data sensors to provide those business insights and analytics. And so we're seeing that as putting some pressure on some of the OT environments. Obviously, regulated environments a little bit less so.
Yeah, and I couldn't agree more with that, Mark. The cloud gives you the ability to store unlimited amounts of data. It gives you almost unlimited capacity from a processing perspective. So doing predictive analysis, predictive maintenance, looking at your data and identifying new ways of cutting costs or even generating new products and services, really the cloud makes it so much easier to be able to do those functions today.
Oh yeah, and things like going from, hey, I want predictive, there's this sort of progression in this where we need to get some data on this. Okay, now we need to get predictive analytics to see when we think they're going to fail because we have a fleet of 10,000 elevators or whatever the case may be. And then sooner or later it gets around, we're starting to see business models of, well, it's just elevator as a service. We're just going to pay you a fee and we don't want to deal with any of the elevator stuff. You're the expert on the elevator, we're the building people, right? And so we're starting to see this really interesting specialization there, again, depending on, security sensitivity. We're not going to have nuclear power generation as a service per se. It's already kind of done in a different way. And so the controls that we see traditionally are very heavy on isolation and segmentation, right? And so you have the hard boundary, the soft boundary, that sort of physical, there is no cord, there is no cable, there's no connectivity. There might be a data diode for a one-way connection, but that's sort of the hard boundary. Now the soft boundary is a little bit more of, as you're saying earlier, next generation firewall, something that is very carefully filtering the traffic on it. Again, depending on the risk appetite of the organization, the risk posture, and the risk goals. And then occasionally we do see a little bit of internal segmentation within the environments. These do tend to be a little bit more predictable in their traffic from the IT environments because the machines tend to do the same thing every hour, every day, whereas users and humans are a lot less predictable, and we tend to be a little bit harder to predict. So we do see some of that internal segmentation, but it is a little bit on the rare side. And so now, okay, how do we bring security into this? So let's talk about how Microsoft has approached this. So Microsoft purchased a company called CyberX and has integrated that fully into what we now call Azure Defender for IoT. And the way this works is very, very sensitive and tailored to the constraints of the environment. One of my least favorite stories is, someone earlier in their career said, hey, we're going to do a port scan to see what's going on and what vulnerabilities we actually have in this environment. Great. Well, that port scan actually caused a bunch of systems to lock up, some of which were 100, 150 miles away from the nearest technician who had to drive up there, go to that windmill, climb up the thing, reboot the computer in the middle of the windmill in the wintertime. So you just got to kind of keep that in mind that these things operate differently. They're a little bit more fragile. They're sensitive to change, and so your standard tools don't necessarily apply. And in the CyberX now Microsoft Azure Defender for IoT solution is designed absolutely with that sensitivity in mind. And we start with a very simple network tap or span port, so we're looking at the traffic in a completely 100% passive way, not putting anything new on the network or out to these devices. And then we have a sensor with some local analytics that do the analytics on there. And you can just look at that at the plant security console if you're interested. Sometimes it's very interesting to the folks that are running these lines what devices do I actually have? Because they got hired 5 years ago, and the devices were here 20 years ago. So what is in this thing? And of course, the security insights as well, not just the inventory, but are there any attacks? Are there any anomalies? Anything unusual that's going on here? And then typically these sensors are then forwarding their traffic to, in many cases, a locally configured Azure Defender for IoT console that has the manager with the security console attached to it. And that gathers that data from multiple different sensors, and then you can have a view across your production lines, across your sites. And in this configuration that we're showing right now, completely offline. There is no cloud, there is no internet, this is just there. In fact, it might even be in the OT environment. It doesn't have to be in the IT environment, but it typically is. And so this is sort of the offline configuration of Defender for IoT. And then because the cloud does bring so much, not just as we were talking about business analytics, but also in security analytics and security insights, we offer the option to connect it to the cloud through Azure Sentinel. And basically you get all the advantage of that real-time threat intelligence, the context of 8 trillion signals a day. So you can take what is already there and really good detections of threats and anomalies and inventory of what's going on. And you can then integrate it into your existing processes and your security orchestration and automation remediation, your source solution in Azure Sentinel, and use some of the built-in playbooks. And there's a lot of native support for the plugins there within that. And so that's sort of the two different configurations that we offer, because we want to respect that environment as it is, but we also want to offer the option of either offline or online connection. Hafid, any thoughts there?
Yeah, Mark hit the nail on the head there. The OT IoT environment, very sensitive. So the use of the typical tools that we use inside a corporate environment, IT environment to do scanning really can cause downtime for your operations in the plant. So work with the engineers before you do anything like that. With the Azure Defender for IoT, I'll tell you what I love about it is the fact that it's very passive in nature. You don't have to really take agents and install them on any machines. The fact that it works in a passive nature gives you the assurance, and it gives the engineers the assurance that it's not going to impact the operations of the plant. It's not going to impact the equipment. And given many of our customers who have infrastructure that is distributed across the globe, that is in the field in remote areas, if there is a new device that's being added to any of your field capabilities, you can identify that fairly quickly. So you always have insight into what is being added to your inventory, what is being removed, especially when you talk about some of the cybersecurity requirements where one has to have full view into their assets and completeness of their assets in order to understand what they're protecting. And then certainly the fact that you can pull all this data into the Azure Sentinel and be able to correlate it with other IT data is really awesome. I think about, for example, 2 incidents that happened a few years ago, one at a steel mill in Germany, where it started from a phishing event. Then it ended up with the plant not being able to shut down the blast furnace in a normal fashion. It ended up blowing up. So luckily nobody got hurt in that event. And then the Ukrainian electricity that was shut down to over 200,000 customers in the middle of December, a very, very cold time. All those started really by coming in from a corporate environment all the way to the OT environment. CyberX really gives you that nice connection of being able to identify threats, identify threat vectors, and deal with them before the cyber threat actors even exploit them. So really, really love that tool and the fact that it works really in a nice, quiet way, if you will, for the OT environment.
Awesome. And the last thought before we close out here is, from a detection and response perspective, love the Azure Defender for IoT. As you think about your isolation and segmentation, one of the biggest things that we see that organizations sometimes make the mistake or inadvertent mistake of is they kind of do what I call a firewall and forget, right? Where they just set up a firewall rule and then they don't really check it, they don't audit it, they don't do a penetration test. And they don't really have a process for, okay, we have an exception now. Like we have, the vendor that supports the machine needs to bring their laptop in and connect to it and make some settings changes for our new production line or whatever it is. And we've seen organizations that actually got taken down through variants of the WannaCrypt virus or worm actually. And we've seen some instances of that happening. So it's really important to avoid that firewall and forget, and really think about when you do that isolation segmentation, that's like putting up a wall. You've got to maintain it. You've got to have a people, process, technology plan for that. We talk a little bit about that in the CAF Secure methodology, but we really wanted to reinforce it here because when you have a boundary like that, you do have to maintain it. So with that, wanted to thank you, Hafid. Really appreciate you coming on here, and want to thank you all for watching the Operational Technology Security Reference Architecture.
Thank you, Mark.